This is brought to you by Forethought, building AI agents for every customer moment.
I'm here with Eiso Kant, the co-founder and CTO of Poolside. Poolside is betting that a focused effort applied to improving AI coding capabilities is the shortcut to developing AGI. Last year, you raised $500 million in Series B funding at a reported valuation of $3 billion. Please welcome Eiso. And for those who aren't familiar, what are you building at Poolside?
So at Poolside, we've been focused on building highly capable foundation models. And as you mentioned, specifically focused on their software development capabilities. But our origin was really around the fact that about 2.5 years ago when ChatGPT came out, the world had a narrative. And the narrative was that all we have to do to get to AGI is scale up more next token prediction, make the models larger, provide more data and more compute. And our view at the time was that the most important scaling axis for reaching the levels of model capabilities at human level and beyond was going to become reinforcement learning. This is heavily biased by my background and what I worked on in 2016. And so for us, when we looked at this, we said, well, what is a domain that lends itself incredibly well to reinforcement learning that is also massively economically valuable and is likely going to impact the world first? And that made us focused on foundation models for software development capabilities.
Why is that the case that software is so amenable to reinforcement learning versus, let's say, robotics or chatbot assistance or something else?
So if we go back 2 years ago, and I think it's changing, by the way, today, the only path that you saw for doing large-scale reinforcement learning required a domain that was fundamentally deterministic, right? You could simulate it. And code is this kind of perfectly simulatable asset. We ended up building a very large code execution environment for this. And at the time, the only path that we saw, I think that's changing now over time, was to be able to scale up reinforcement learning, that you needed a deterministic data set that was massively diverse, that was a good proxy for a lot of what we consider intelligence. I think building software is an amazing proxy. It requires understanding a lot about the world. It requires longer objective reasoning and planning. And at the same time, you could execute the code. And we had this massive data set on the web that was already diverse and would be able to provide some level of deterministic rewards.
And thinking through that, you've said that your models improve today by completing tasks, millions of tasks in actual real-world software products. Can you explain what that is, what is happening under the hood in any meaningful detail there? Yeah.
So we try to divide, it's a bit of an internal terminology, but we try to divide software development and actually the building of foundation models between kind of bread and butter foundation model work, which is just you're constantly improving your data sets, you're constantly improving your architecture, you're constantly improving your compute efficiency, and then really oriented towards, well, what do you specifically do for software development capabilities? Because at the end of the day, what you're trying to do here is raise both the general intelligence of the models, the ability to reason over complex topics, but also their actual ability to work and operate in environments that lend itself to software development. And here what we've done is we've created a code execution environment that today counts close to 1 million real-world code bases. These are all publicly available code bases, and we've made them fully executable. So think of this as a project you find on GitHub that is either already containerized or not yet. We have those as over 30 million container images, fully containerized with the ability to run the code inside of them, execute any of the existing tests, and add any to it. And so this creates this very diverse environment across programming languages, domains, type of tasks. Our next step then becomes, how do you create the tasks in which you want the model, and now the agent, as models are becoming increasingly more agentic, to explore the solution space. And this is almost entirely synthetic. So how do we go from what already exists in that repository and define sets of
new tasks?
New tasks. So it started with, the early stuff was simple back-translated tasks. Take an existing piece of code, remove it, turn it into a task. That over the years has become increasingly more complex. It's gone increasingly from a single-shot approach to an agent long trajectory approach. And yeah, that's effectively the approach we take in there.
I'm curious for the synthetic tasks. When you look at that from the lens of a software engineer, are you satisfied with that quality of task that you can create from a synthetic data set perspective?
It's a really good question. So if you think about RL, you're constantly trying to find the set of tasks that are challenging enough that the model requires exploration to solve them, but aren't so challenging that they're impossible to solve, or at least throughout the training process as
They
the
should
model's
be
getting better.
adjacent kind of to the distribution of tasks that you already have data for, but...
Yeah, so it's kind of an intersection between the model capabilities of that generation model that you're training, the diversity of tasks that you require so that the model actually generalizes, and that's also where skill hugely matters. And then in combination of that, you actually care about how the user at the end of the day is going to formulate a task.
Yeah.
Because we as users are pretty poor at doing so. So the perfectly long, spec'd out task that you create synthetically can help improve the model's capabilities in coding and reasoning, but you also need to be able to kind of build a distribution that allows you to get some of that user ambiguity in there.
Because in practice, the actual specs won't be that clean when you are deployed. Yeah,
Absolutely not.
makes sense. Can you talk about specific benchmarks you maybe focus on for your models at Poolside?
So it starts with the internal benchmarks that we create. And on the internal benchmarks that we create, we kind of subdivide it between hill climb benchmarks, right, the ones that we're really looking to push, and what we refer to as debug benchmarks, like everything you want to see throughout the training of a model, that in case something goes wrong, you have an eye on it. And a lot of our hill climbing benchmarks are very oriented on general reasoning capabilities of the model. A lot of people assume because we're focused on software development capabilities that we're not building a general purpose model. At our core, we absolutely are. I talked to our model about writing a poem or a bedtime story, but we really try to push the software development and the complex reasoning capabilities far earlier in training than some others might, because we only have one end use for the model. And with those benchmarks, you really start breaking it down to what's the spectrum of things that we do in software development. A lot of that's code understanding. Right? So to be able to answer a question successfully that requires some agentic behavior to pull the right context in to be able to answer it. Everything that would fall under code generation, and this really then breaks down into programming languages, type of task, complexity, domain knowledge, et cetera. And then kind of more very specific, type of task. Like how good is the model at code comprehension? How good is it at writing tests? How good is it at having a mental model of a compiler? This is my personal favorite. You can try this on any model today. Models still have a very, very poor mental model of compilation. You can give it a complex piece of code that you yourself can reason over how the inputs to outputs are going to change state along the way. And most models today, or actually all models today, still heavily fail on this. So what we're seeing is that on one hand, we're moving really fast in improving the coding capabilities, but we're still missing some really core fundamental places that we haven't really grokked yet to get to kind of the level of intelligence that we have ourselves when we're building software.
Deep understanding that a human engineer has. It makes sense. And you're focused, as I understand it, on deploying to Fortune 500s, large enterprises with very complex code bases. Why go that path as opposed to kind of participating in the vibe coding craze that we're all familiar with already?
So I'm a huge fan of what's happening in vibe coding.
Yeah.
At the core, I'm a developer, and I think it's incredible to see that technology is being built that opens the aperture for anyone to be able to build software. Where you've seen incredible companies like Lovable and others who are just democratizing the ability for people to be able to create software. For us, if we look at why we started this company and kind of the bigger picture of the next 5 years, we started the company because in 2016, I tried building this company before. I built a company called Sourced, which was, to the best of my knowledge, the world's first company that focused on AI's ability to write code. And at the time, we were doing LSTM-based language modeling, then to transformers, and we were doing RL via compilers in the tiniest setup. But back then, it built this kind of very strong level of conviction that we were going to be able to go all the way to human-level capabilities and beyond with neural nets. And I think as of today, those timelines are only accelerating. And so we asked ourselves, well, what does the world look like 2, 3, 4, 5 years from now? And in our view, when you're building intelligence on compute that becomes elastically scalable, you are effectively adding to the world's global workforce. And then we kind of took a very pragmatic point of view, and we said, well, if we think the global workforce is going to be massively impacted, And we see that other foundation model companies are deeply focused on the consumer side of the house. What is something that we know very well, right? Because it has to be in the DNA of the founders in the company, where we think we can have a massive impact. And that for us was really about how do we build a world where we're powering, an elastic AI digital workforce. And enterprises come with a whole host of complexities that have nothing to do with foundation model building. And so we decided to really double down on those. And for the last 2 years, I've been working on how can you operate AI at scale successfully in some of the world's most complicated organizations.
And then what does that actually look like in practice? If I am an engineer employed at one of these enterprises, how am I able to utilize the poolside technology?
So for a developer, the experience should feel exactly the same as if you're vibe coding at home or if you're using a tool. There's definitely some things that we obsess over in the UI and application layer that we feel lends itself better to professional software development than maybe vibe coding an app. But at the end of the day, the form factor is changing very rapidly on top of the models.
Yep.
So I think our premise today, and I think it has evolved since over the last 2 years, is everything is increasingly collapsing into the models. Now we are starting to deliver agents where the agent itself, the code, the binary, is trained in the RL loop. So effectively, the agent is becoming the surface area, but the agent is a thin wrapper of code over the model in software development, and this is not the case in many other areas. And so our view is that the first layer on top of the model is an agent. The layer on top of that is the user interfaces that you interact with. And the surface areas that matter today and that we focus on is the editor extensions to be able to both synchronously work with an agent, right, real-time back and forth, asynchronously send tasks off. The second surface area is headless. Our view is that agents will be running in places where developers aren't interacting with it. That's within CI, that's in systems that are operating, observing logs. It's effectively everywhere where code is running and potentially throwing errors or being modified. And then the third is really just the standalone outside of your software development environment, if that's a CLI, if that's a web assistant. And we've been building those surface areas on top of our model. But we also are very open here. We think that over time, other people might do a much better job at the application layer than us. I think we feel we're doing a very good job. But as developers, the form factor will continuously change. We'll all have our preferences. So we think focus on the model, focus on the agent, build out our own opinionated views of form factors, and then get closer and closer to allowing anyone to build on top.
And what makes it hard right now for these enterprises to adopt either poolside or these other models from foundational labs for engineering? What is it about enterprises that is challenging still? Is it the complexity of the code base, or like you said, more of the human aspect of software engineering? Where are you seeing challenges?
So I think you can break it down between deployment challenges, so security, like logging, audit logging, call it the boring set of enterprise features that really matter.
Right.
And then what does software engineering look like inside an enterprise? And you're right, software engineering inside an enterprise is extremely large code bases.
Right.
So you want your model to be able to essentially navigate these things quickly and fast. And model capabilities today are still far from human level capabilities. So often when you're dealing in your home project at home, smaller code bases, et cetera, you can get your answer relatively fast. You can get the context pretty well set up over multiple reasoning steps. I think in larger enterprise code bases, that still requires more scaffolding around the model. I think.
And is that sort of custom for? Are you finding that to be a sort of a per deployment effort in some sense?
I think we're very focused on building the infrastructure, so you're not building custom solutions enterprise to enterprise. Yep. I don't think that's
scalable.
It's scalable or a winning model, to be honest. And all of it with the sight on the fact that we are now on a trajectory where enterprises in the next 24 months are going to be running thousands or tens of thousands of agents. And that's where actually that first bucket of challenges comes in. How do you manage 40,000 agents that are being spun up all over your organization that have access to a whole host of tools, different data sets? What's the role-based access control look like? What does the logging look like? All of these questions that essentially are like as if you're adding to your workforce another 20, 30, 40,000 people. How do you manage that world? So there's a lot of interesting things that we end up building around that space.
And do you think that will be something that emerges that manages agents outside of coding, or do you think it's necessary for you as poolside to kind of manage the coding aspect of that workforce? Or
So the head fake behind poolside, and this has been on our website since day zero, was always our three-step plan. And our three-step plan was, we exist as a company to achieve AGI. Our step one is to assist developers. Our step two is to allow anyone to build software. And our step three is to generalize to other domains. Yep. And the reason we've always focused on software development is because we found it this great proxy task for intelligence that's valuable. But I do think if you zoom out over the course of the next 5 years, a lot of this infrastructure looks agnostic to what the task or the domain is.
And so that is where you are setting yourself up for success on that shortcut to AGI. And thinking about when you started versus where we are today, how do you feel things are playing out in terms of the timelines to AGI? Is it sort of emerging as you might have expected?
So 2016, it was, we know we're going to get there, but it's an entire blur to timeline. I think, late 22 was, we're now on an accelerated trajectory. And you would have heard me say things like 5 to 10 years. But 5 to 10 years is founder speak for, I know it's coming, but I don't really know when.
Yeah.
Let's just call it what it is. I think in the last 6 months, it's to my definition of human-level capabilities and intelligence across the vast majority of knowledge work that we do behind the laptop. We're now in under 2.5, 3 years away from that.
And what is it that gives you the confidence to say, hey, there will be in 24 months, 40,000 agents running in some of these companies?
We have a scaling axis now. Right? The scaling axis of larger parameter size was always going to be limited by the amount of data we had in the world. And the web is an incredible data set, but it was missing really the large-scale data of reasoning to get to that data set. Right? You've got the output of code, but you don't have the entire thinking and action process that led to the creation of code. And this holds true not just for code, this holds true for almost anything that sits on the web.
Yep.
And now through reinforcement learning, we have a scaling axis, not just on verified rewards, but line of sight on unverified rewards as well, to be able to truly start scaling up like this missing data set.
Yep.
And so my view and prediction is that if we look over the next 2 years, more compute will go to reinforcement learning than any other stage of training of a foundation model.
And this is going all the way back to that idea of synthetic data. You're seeing that that's sufficient enough to create the intelligence scale that you are looking for.
Look, effectively, if we had infinite data in the world and infinite compute, we'd all be at AGI, right? Yeah. The optimization pressure of next token prediction is incredible if you had that massive data set. Yeah. So now it's about, it started with in the last 2 years, how do we move to a world where we have these verified rewards and execution environments where we can push these capabilities. Now we're seeing how that's going to potentially extend beyond to unverified rewards as well. And that's kind of what we're excited about.
And so if we're all back here in a year or 2 years, like how will we know, what is the milestone that you're on that track, at poolside to AGI?
So I think first and foremost, my head of comms will slap me over the back of my head after this, but like the reality is look at the size of someone's cluster. It's a very honest answer. There's a direct relationship between the amount of compute that you are deploying and the intelligence that you can create. It doesn't mean that not year on year we're getting far more efficient. And then I would say that the second part of that is just what you're seeing with the models, right? We're already experiencing this on a day-to-day basis. You're seeing the models get increasingly more capable. Now, who is then in that frontier race is really determined by, are they on a trajectory where they're able to show that increasing capabilities of models? All of us are converging effectively on a similar point. Intelligence is a commodity that we're creating. We might specialize it in different domains or different areas, a little bit more left to the right, but all of us are going to end up in a world where we've effectively come to the same point. Mm-hmm. And so to be able to look at us, I think it's around, of course, seeing our model capabilities, seeing where we stand, but also in general in the landscape of companies that are challenging the frontier of AGI is look at the size of the compute cluster.
Great. We'll check in soon. Thank you.
Sure. Thank you.